Hello, sir. My name is Chaudhry Kushagraj, and I am presenting my project on conflict-based search and heuristic for multi-agent pathfinding. Okay, so I'm going to use certain abbreviations in my presentation. They are as follows: BMAA star, bounded multi-agent A star. NPC is non-playing character. It is in reference to video games. FAR is a flow annotated replanning. It's an algorithm for heuristic search. RTHS is real-time heuristic search, and RTA A-star is real-time adaptive A-star. So the problem statement is to find a collision-free path for AI agents to move from their start node to goal node. Okay, so the graph, the n agents are operating in a given graph, which is a set of vertices and interconnected edges. Agents can have two options at each time. One option is to go to another node. This has a non-zero cost. The second option is wait at the current node. This this has no cost. And another constraint is that at each time there can be only one agent in a node. Okay, so there are two types of conflict. Uh, when two NPCs or AI agents arrive at the on the same node at the same time. The other type of conflict is when two NPCs exchange node. That is they are on the same edge. So, in other words, there are two types of collision possible. One is at a node, and second is at an edge. So, conflict-based search is a two-level algorithm used to find optimal collision-free path for multiple NPCs. Here, the high-level tree constraints simulate plans in order to search the conflicts. Whenever we find a conflict, we we have that point have children. Like here, the yellow shade shows a conflict, and the purple shade shows resolved conflict. So whenever we find a conflict, we then use the second level, the low level graph search, add a constraint, and calculate a new path to avoid conflict, and then it repeats. So in general, conflict-based search, even after finding a solution, we have to explain it. Means to validate the solution, we have to simulate it. It will take a large amount of time. To avoid it, we can use explanation guided conflict-based search, where even if the obtained solution is not optimal, it can be obtained faster and require no explanation, which is more cost effective. Uh, eh, this is the general procedure of CBS. Here, whenever we encounter a conflict, it shows in it it splits into its children to with an added constraint to show all possible paths. Uh, the diagram at the bottom is an explanation guided CPS. This diagram needs no explanation. It at least shows that there is no conflict. Uh, so, uh, so by CBS, we have some of the lowest cost possible, like the three diagrams. These have the lowest Manhattan distance, but we also have these two solutions. These have higher paths. Uh, so even though some solutions are has best cost, there are other solutions obtained via explanation guided CBS which have higher cost. Like here, the solution at the bottom, it does not require an explanation, but it has a higher cost to enhance, and it can be found faster. Okay, so this is multi-agent pathfinding with real-time heuristic search. Since it's real-time, we have a fixed time limit to provide a solution. So we are not focusing on the complete solution, just the immediate solution. For example, if a player retask an NPC or if the map changes, we only need the immediate solution. An extra term is added to the heuristic of each NPC. This extra term ensures that there is a certain minimum distance between two NPCs, and hence, due to this extra term, the NPCs wait instead of collide. In such a scenario, the deadlocks may occur, so we use FAR algorithm. FAR, in a flow annotated replanning algorithm, which attempts to break the deadlocks by converting the undirected edges into directed, essentially converting two-way road into a one-way road to divert traffic. Real-time adaptive A star performs an A star limited to a given number of nodes, and bounded multi-agent A star is just like the RTA A star, but it has a large number of NPCs. In other words, large number of AI agents, and each AI agent has its own copy of RTA A star. So the parameterized learning of BMA A star, there are 5 parameters. The expansion, gives the number of, this puts the limit to the number of nodes which can be expanded. The vision, uh, this gives the maximum distance up to which we can an NPC can see other NPCs. Then moves, this gives the number of moves an NPC makes before its paths get updated. In other words, this gives the amount of time the AI agent has to calculate its its updated solution. Then the final two parameters are the Boolean parameters. The if the push is true, then that allows an NPC to push other NPCs temporarily off their nodes. For example, in a situation like the only path to the goal node is blocked by other NPC who have already reached its own goal. So in that case, push is allowed. Then the final parameter is flow. If flow is true, then the RTA ASR can use the FAR algorithm. So to summarize, there are certain differences between the conflict-based search and the BMA A-star. Like the conflict-based search is a global coordination, but the BMA A-star only focuses on the local coordination. Conflict-based search can find the optimal solution, but the BMA A-star does not focus on finding an optimal solution. It focuses on finding the solution faster. Doesn't matter if it is optimal or not. Since conflict-based search has uh, global coordination and optimal solution, it can be obtained operate in real time because it requires large amount of time. On the other hand, a BMA A-star can operate in real time. In conflict-based search, it guaranteed to handle conflicts. If there exists a solution without any conflicts, it can be found by CBS. But BMA A-star does not focuses on finding such solutions. It focuses on just moving the NPCs faster or moving the NPCs continuously. Uh, then the conflict-based search has high time and space complexity, but BMA A-star has low time and space complexity. We can also see that conflict-based search is not scalable, but BMA A-star is scalable. So these are the references I use in my project. Thank you.